Okay, working energy, multiple choice 2. Pardon me. Number 14. Number 14 is a bit unfair. When I initially assigned it this year, I had not realized that it uses the word momentum, and we haven't really covered momentum, so you may have panicked. But you know what? I'm going to throw it in anyway, because once I say what momentum is, and a couple things about it, it should be a pretty easy question. So this is a good way to preview momentum. So it involves a pendulum that goes from its highest point at rest and falls to its lowest point. And we've done enough work with this to realize that this is when it's going its fastest, correct? And then it starts slowing down up here. So here's the thing which you need to know momentum. Momentum is, first of all, don't ask me why, but the letter we use for momentum in an equation is lowercase p. I guess m was used for a bunch of other things, and so some meeting somewhere they decided let's call it p. I don't know why. All momentum is actually a relatively simple idea. It's mass times velocity. This is where if you're taking calculus, keep listening. If you're not taking calculus, then you could pay attention but not worry about it. Calculus people, I want to point out that kinetic energy, you know, is 1/2 mv squared. If you take the derivative of this with respect to v, so v is your variable and m is just a constant, what do you get? So you take the 2 and you multiply it, so you get 2 times 1/2, that's just 1. Decrease that exponent by 1, and holy crap, we get momentum. So the rate of change, the instantaneous rate of change of kinetic energy is momentum. What? Yeah. It's not all that important for what we're doing right now, but I thought it'd be interesting to point out. Okay. Welcome back. The momentum is this. Here's the other thing you want to keep in mind. So it's just mass times velocity, no big deal. What is a big deal is momentum is a vector. In other words, as you know, direction matters. So the pendulum bob here has two things occur to it in terms of momentum. It does speed up, right? Its momentum here would be 0. Wouldn't have a direction because there is no direction for 0. But like say here, its momentum would be directed, say like that. But here it would be directed more like this, and down here it would be directed horizontally. And it's speeding up as it does this. So a student that wants to try to understand all this, I would pause the video and go look at your answers and see if you can pick the one that makes the most sense now. Welcome back. Hopefully, when you looked at your answers, it says remains constant because momentum is always conserved. That's if all the forces are internal. Gravity in this case would speed it up, be considered an external force. So yes, while momentum is conserved, only for, if we look at the system is, no. So this one doesn't work. B is our right answer. The momentum increases in magnitude, right? Because it went from 0 to something faster than that. And it changes direction. Yeah, it's going here, it would be pointed this way when it first starts off, and then down here it would be pointed this way, so on. So that's our right answer. But let's see, decreases in magnitude. No way it decreases in magnitude. Yeah, that would mean it got slower. And it gets slower. Is converted to angular momentum. Converted to angular, that, we haven't covered angular momentum either. Really, it has, you can either look at it from a point of linear momentum or angular in this case. But it's not like one changes into the other. It's really just two ways of looking at it. You can look at this as a rotating object or just an object that's falling, right, due to gravity. So, yeah. Converted into kinetic energy. Well, wait a second. Momentum and kinetic, they're not, you can't convert. They're two different concepts. So you really can't convert from one to the other. That's like, I don't know, converting your money into, I can't even think of, I can't even think of a good analogy, but that doesn't make sense. They're two different things. So this is your right answer for that one. Because the momentum, because it speeds up, the momentum's magnitude increases because that number gets bigger, but its direction does change, and that's important for momentum because it is a vector. All right, there you go.